Okay, so we saw what a coefficient is. So the constant part in a term is called the coefficient. So the coefficient here is 5 minus 2 minus 3 by 2 and 1. So for constants alone, so if we write only constant, we call them as constant polynomials because the variable part in there is represented as x to the power 0 or y to the power 0, z to the power 0. So they are called as constant polynomials, and the coefficient of a constant polynomial is the constant itself, that is 9. However, in the case of 0, we call it as 0 polynomial because 0 can be written as 0 x to the power 0 or 0 x square, 0 x to the power 2020 or 0 x to the power 2. So it is all 0. So the coefficient of a 0 polynomial is 0. 0 is called as the 0 polynomial, whereas a constant is called the constant polynomial. Now let us look at different types of polynomials. So a polynomial in which there is only one term is called a monomial. Okay, this is monomial. Please correct it as M, monomial. A polynomial in which there is only two terms. Okay, so here 3u is a term, 5 is a term, is called a binomial. X square plus x, we have two terms. And if a polynomial has three terms, x square, x and 3. So if there are three terms in a polynomial, we call it as a trinomial. And if there are 4, 5, so from 4 up to from 4 and above, we call them as polynomials. Okay, so monomial, binomial, trinomial, and any expression that has any polynomial that has more than 4 terms, more than 3 terms is called a polynomial. So now how do we represent polynomial? Polynomials are represented by some small letters, let's say p bracket x, and we read it as p of x. That means this is a variable, this is a polynomial of the variable x. Q of y, so this is a polynomial of the variable y. This is a polynomial of the variable z. Okay, so this is represented as a small letter. Usually we use p, q, r to represent polynomials, and we represent them as p bracket whatever the variable is being used there, that variable is put inside the brackets, and we read it as p of x, q of y, r of z. So now I would like you to look at, so consider the polynomial p of x. So which term has the variable with the highest power? So here we can see 2x to the power 7. So this term has the variable with the highest power. Okay, so the highest power is 7. In the second polynomial, we have 3 terms, and y cube has this term has the variable with the highest power. So here the highest power is 3. The third example, we have 3 terms, and the term root 2z to the power 4 has the variable with the highest power 4. Okay, so we call the highest power of the variable in a polynomial as the degree of the polynomial. So here the highest power of the variable in any given of the all terms is 7, because the first term has x to the power 7. The degree, the power of the variable x in the first term is 7. So this is a polynomial of degree 7. Okay, so the highest power of the variable in a polynomial is called the degree of the polynomial. Here the highest power is is in the first term, that is 3. So this is a polynomial of degree 3. In the third example, we have 3 terms and the highest power is in the first term. Here the highest power of the variable z is 4, z to the power 4. So this is a polynomial of degree 4. In the case of constant polynomials of constant polynomial 5 can be written as 5x to the power 0. So here the power of the variable is 0. So the degree of a non-zero constant polynomial is 0. Okay. Now if we take the zero polynomial can be written as 0 times x to the power 0, or it can be written as 0x to the power 3, or 0x to the power 1000. So if I say the degree of a zero polynomial is 0, another person can say it is 3, another person can say it is 1000, another person can say it is 10,000, because all of these are correct. So if I say uh, it is 0, because I am saying it is 0 because I have written it as 0x to the power 0 and the power of the variable here is 0. The second person can say it is 3 because he can write it as 0x to the power 3. So what he is saying is also correct, because here the power of the variable is 3 and the expression is and the number is 0. So in general we can say the degree of a zero polynomial is not defined, because all these answers are correct, because the zero polynomial can be written in infinite number of ways. The degree of a zero polynomial is not defined, whereas the degree of a non-zero constant polynomial is 0, because it is written as 5x to the power 0. Okay, here it need not be x, you can replace it with any variable, it could be any variable. I've just taken x because for my convenience. Okay, so now that we have seen what is the degree of a polynomial, now let us see how polynomials are classified based on their degree. So if the degree of a polynomial is 1, here the highest power of the variable is 1. So this is the degree of this polynomial is 1, q of y. The degree of the polynomial q of y is 1, and such a polynomial is called linear polynomial. Okay, so if the polynomial is of degree 2, here the highest power of the variable is 2, such a polynomial is called quadratic polynomial. And if the degree of the polynomial is 3, then we call it a cubic polynomial. So if we get a polynomial of degree 4, we say it is a polynomial of degree 4. So if it is a first degree polynomial, we say it is a linear polynomial, a quadratic polynomial, cubic polynomial. From 4 onwards, we say it is a polynomial of degree 4. It is a polynomial of degree 10. It is a polynomial of degree 100. Okay. So I hope you understand how we classify polynomials based on their degree. So a polynomial can have any finite number of terms. So here we saw there are only 2 terms. Here there are 3 terms. So I can write any finite number of terms. Here I am starting with x to the power 150, 149, and so this is a polynomial, okay, in which there are 151 terms. If you want, you can write a polynomial with 1000 terms, with 10,000 terms. So there is no limit on the number of terms that you can use inside a polynomial. So a polynomial can have any number of finite terms. So you can't start something like x square, x cube, x to the power 4, and this goes on. This doesn't have an end. No, it cannot be infinite. It has to be finite, and inside the finiteness you can have any number of terms. Okay, so it cannot be infinite. You cannot have a non-ending sequence of terms, but it has to be finite, and you can use any number of terms using the finite number of terms. So the general form of a polynomial. So here if we see, how do we write the general form of a polynomial? So that is written as an x to the power n, an minus 1 x to the power n minus 1 a. So if you look at the first example, the x to the power 7 term has a constant or has a coefficient 2. Okay, so in there is no x to the power 6. X to the power 6 term is missing, x to the power 5 term is missing, x to the power 4 term is missing. Then we have x to the power 3 term. There is x to the power 2 term. Then we have the x term is missing. Then we have the constant term. So in general, we can make a general form of this as an x to the power n, an minus 1 x to the power n minus 1, so on, a2 x square, a1 x, and a naught. So this an is the coefficient of the x to the power n term, an minus 1 is the coefficient of the um, x to the power n minus 1 term. So this is a constant. See, just like this, the constants vary in different polynomials. This is a constant term. Okay, the ans here represent a constant, whereas x to the power n represents the variable. I'll show you with an example. See, let us look at this term, this polynomial 2x to the power 7 plus 8x to the power 3 plus 9x square plus 12. So we have written the general term here. So this we can represent it as 2x to the power 7, 0x to the power 6, because there is no x to the power 6 term, x to the power 5 term, or x to the power 4 is also there. I have forgotten to miss it. Oh, this is x to the power 4. Okay, this is x to the power 4 plus 8x to the power 3, 9x square. There is no x term and there is 12. So if we write a7, okay, an x to the power n. So a7 x to the power 7. So the coefficient of the x to the power 7 term is 2. Can you see? So this is a7 x to the power 7 minus 1. So we have a6 x to the power 6, and a6 is 0. Then we have a5 x to the power 5, which is a5 is 0. Then we have a4 x to the power 4. Okay, kindly, this is by mistake, a4 is 0. Then we have a3 x to the power 3. Here a3 is 8. This is 8. Okay, I'm sorry, this is 8. Then we have a2 x to the power 2, and a2 here is 9. Then we have a1 x to the power 1, and a1 is 0. And a naught or a0 is a constant term, that is 12. So the a0, a1, a2, these are all representing the constant parts or the coefficient parts, while the x power 7, x power 6, these are all representing the variables. Okay, so the general form of a polynomial can be written a polynomial of degree n. Okay, this is a polynomial. So the general form of a polynomial of degree n can be written in this form. So if it is the general form of a polynomial of degree 7, it would be a7 x to the power 7, a6 x to the power 6, and goes on. Then we have a2 x to the power 2, a1 x to the power 1, and a0. Okay, so if all the coefficients, that is if an minus 1, all of these become 0. Okay, so if an minus 1, all of these are 0, we get the 0 polynomial, which is 0. Okay, so now let us look at polynomials in many variables. Till now we have seen only polynomials in one variable. So we can have polynomials in two variables also, x cube and y square. These are polynomials in two variables. We can have it in three variables. Here we have z, y, and x. So polynomials can be in many variables: one variable, two variable, three variable, or any number of variables can be there. So polynomials can be of many variables. It can be of one variable, it can be of two variables, or it can be three variables, or four variables, five variables. It can be of any. So polynomials can be in many variables. So we shall be interested in studying polynomials in one variable. Okay, let us look at an example. Find the degree of each of the polynomials given below. Okay, so the degree of a polynomial is the highest power of the variables present in any of the terms. Okay, so here we have three terms. The highest power of the variable is in the first term, x to the power 5. So the degree of the polynomial is 5. In the second example, so the highest power is in the last term. The power of the variable y is 8. So the highest power of the variable is 8. So the degree of the polynomial is 8. Now in 2, the only term here is 2, which can be written as 2 into x to the power 0. So the exponent or the power of x is 0. Therefore the degree of the polynomial here is 0. Okay. So with this we come to the end of the first section. Okay, so I hope you will do the exercises and try out the example problems. Thank you.